welcome everybody who's joining us today. We are super excited to have you here for July's community call. You might have missed us last month, but we were all busy with HasuraCon, so hopefully you actually joined us there. We had a really great time. We saw amazing talks, and that was, I think, a worthwhile reason to skip for a month. So yeah, I was super excited to be back. We got a lot of really interesting features to be showing you all today. And without any further ado, we're going to go ahead and just run through our agenda here. So what we're covering today, we've got BigQuery is now generally available. So woohoo if you're a BigQuery person. Plus computed field support, which is fantastic. So Abby and Rakesh are going to be giving us a tour of those features. We've got the how Hasura implements MySQL event triggers using kind of some foolery with complex indexes. So Rakesh will give us that deep dive. So this is sort of a Hasura internals talk. Then we've got a really cool streaming subscription benchmark, which is, I think, really impressive. So Karthik's going to give us that rundown. And then we've got naming conventions and GraphQL customizations are now in console. So if you are not a metadata person, or if you are, but you still like to work with the console, yeah, you're welcome. And then we've got parameterize array variables and subscriptions with Tom Harding. So hold on to your seat. In the very end, we have our community contributor, Enrique, who's got a really cool bot that he made with Hasura. So we're going to be able to see sort of this really cool integration about how you can sort of build like chat apps and stuff. So we've got a really full show today, super excited about it. Without any further ado, we're going to go ahead and actually just kick it off with the BigQuery talk. So Abby, are you ready to go?
My name's Abby. I'm part of the native databases team, and our responsibility is for the backends, including Postgres, BigQuery, and SQL Server, and as well as kind of Postgres flavors like Citus. I'm going to give a very brief demo into some of the capabilities that we now have on BigQuery, such as queries, permissions, and nested relationships. And then I'll hand over to Rakesh to see what he's been working on. So I've split my screen into two. On the right-hand side, we can see that I've got a BigQuery data set in the Google Cloud Platform. I have a small data set called library with articles and authors table. You can kind of see the schema there. I'm not going to do a demo with a humongous data set, but you can basically do all of the same things regardless of the size and number of data sets that you have. First thing I'm going to do is connect to a BigQuery database. So I have the options here to connect via a service account key or an environment variable. I have a service account set up already. And because I don't want to kind of expose that too much, I'm just going to copy and paste that in a different window so you don't see all of my service account details. Connect the database and refresh this page. And if by magic, I should now have access to a BigQuery dataset and also access to the library dataset within the BigQuery data source. Next up, I want to track all of my tables, both articles and authors, so that I can have access to kind of querying capabilities. And the way I'm kind of going to briefly structure this demo is to also show off the documentation that we have. So these are just the standard Hasura docs. And we've recently, or rather the docs team have done a bunch of work to update and make more clear the capabilities that we have across all of the different backends. So today I'm going to be illustrating simple queries, relationships, and permissions on BigQuery, and I'll kind of use the docs as a bit of a pointer to do that. So the first thing that I'm going to do now that I've got access to my tables is just run a really simple query and just illustrate that works. That's nice and easy, but we automatically have access to as many as the data sets that you've tracked on the Hasura console. Next up, I wanted to take a look at relationships. So sort of taking a look at the nested object queries. Each of these little checkboxes links to the things that you can access, the documentation that you can access on the right-hand side. So in order to set up relationships, I need to go back to the data manager. I'm going to set up a relationship on the articles table. Oh, I should mention here that because BigQuery doesn't have a notion of kind of primary key or foreign key constraints, we can do this all manually via Hasura. So that's something quite nice that just introduces some consistency across different backends. I'm going to introduce an author relationship on the articles table, referencing the author ID across the two different tables. So that's one object relationship. I can also configure an array relationship here. From the author ID to the article ID. Sorry, I've done that one. So that, and then we can see for both tables, we have those relationships configured. Then when I try to run a query using those, for example, I want to see an article with all of their authors, I can do that, and I have a full list of the articles along with their authors and the author name and whatever other information you want to link to. So that's quite an interesting thing that we can do via Hasura that actually we might not be an ideal use case for a lot of BigQuery datasets, to be honest, but it's something that we can do consistently across all of the datasets that we have. Last but not least, I wanted to show permissions or some kind of the data validations docs. So I'll go back to the data manager and introduce a permission on the articles table that says that the author should only have access to the articles that they've written. So I'm going to apply a custom check on the author relationship and say that the author ID must equal the current Hasura user ID. So if you were in an application or something, the author was previewing this via some kind of UI, then they should only be able to access the articles that they've written. Before I run that query, I need to update the request headers to specify the role that I'm using and the user's ID, and then I should be able to run that query. And here it just filters on the articles for that particular author. So that's me. I'm just going to wrap up really, really quickly to give Rakesh some time to demo what he's been working on.
Thanks for Abby for this presentation. I will continue the BigQuery. We also have the computer field support. As some of you guys know, we have the computer field support in Postgres. Similarly, we did the same in BigQuery. What are computer fields? Computer fields are nothing but if you have a function, an SQL function that returns a table. So in BigQuery, create table function is a syntax that defines a function which returns a set of table. We mean a set of rows. So we can add this function as computed field. What does that mean? So if you have any function that returns any set of rows, and if it takes any input, let's say in this case, it's a fetch article is a function, it takes an author ID, and it also takes a search string and gives you a list of articles of that author ID where the the title or the content has the search string. So yeah, so let me demo the same. So here is my GraphQL. GraphQL. I'm running GraphQL engine locally. You can see the logs here, and this is API console. And then here is my BigQuery source. I have a dataset named communities called demo. Let me show my BigQuery dataset. So yeah, this is how the BigQuery dataset looks like. I have given the env variable for a service account, and then yeah, my project ID, and then the data set. So fine, let me show the article and author table. I have a few articles and then a couple of authors. Fine. Let me add a BigQuery computed field. So to add, we can add a lot of ways, but console support will be added soon. Let me try with that API. So we can use BigQuery add computed field API to define a computed field for a BigQuery table. So have that the request ready. Before that, let's add a function in our data set. So let me copy this function definition and then go to data tab, SQL, and then add this function. Function is like fetch articles, which takes an author ID argument and then gives bunch of articles of that author ID where the search string matches. Like, let me add this. Fine, execute it. Let me also add the computed field. Let me also define the computed field. So if you see the computed field, I'm defining for the author table in the dataset community called demo, and then the name is fetch articles, and the function is fetch articles, and also we should also specify which table that computed field returns. So it returns article table from dataset. So and also argument mapping. So argument mapping in the sense like what what input argument of the computed field, I mean the function has mapping, which means like the column value, uh, the the column value will be mapped to the input argument. I will show you how this works after adding this computed field. So let me copy this and let me, so I'm just doing a curl request to add this computed field. Right, done. uh, just added a computed field. Let me check. So this is my community called demo author. Let me just fetch author. Yeah, I'm fetching id too. Let me also fetch articles. I just had a query search article where I'm searching on keyword second. Fine, second article written by allies. Let me also search this keyword. Cool. Article written by allies with a keyword. I'm able to search that article. And also let me show the SQL that is being generated. This is the SQL. Let me copy and paste it here. See. So here we are actually calling the function here, like from community called demo fetch articles, where the search will be a param1. So we use the parameterized queries. So param1 will be our search keyword, the name, and then author ID argument will be the author's ID, t.author ID. So yeah, by this way you can add like different computed fields and by using the functions, and also you can refer to these documents, and please let us know, please try this out and please let us know your feedback. So yeah, that's it.
Yeah, that was a great demo. And so if you got other questions about BigQuery, definitely hit us up in the chat, and we'll be happy to answer those as we go along. Our next chat talk we have tonight is going to be about implementing MySQL event triggers and how we've done that inside of Hasura. So Nikesh is going to actually give us the run through on how we've built that.
Yep, awesome. So hey folks, I'm Naveen, and today I'll be talking to you about how Hasura uses complex indexes for event triggers. And I see Brandon is also on the call, so if I do make a mistake, please do correct me. And let's go. So yeah, so before we jump into it, let me try to give you a very brief intro of what event triggers are. So Hasura events basically are nothing but it's a mechanism where we use to reliably capture events from any tables, and once we get that event, once we get that payload, we just transfer it to any webhook for whatever business logic a user might want to do. So the one thing that you might have to remember for the entire talk is that the events that we capture is stored in something called as event log table. And Hasura keeps fetching those, keeps polling that event log table to fetch the top 100 undelivered event. So this looks pretty simple, but what's the actual problem here? The problem here is that the event log table, that's the Hasura events, the size of that may keep on increasing. And once it keeps on increasing, the question comes, how do we efficiently fetch the top 100 undelivered events from this table, right? So one might ask, why can't we just use a sequential scan? But the problem with the sequential scan is, say, I have somewhere around 10 million rows, so 1 million rows, and I would like to fetch 100 events. The time it would take me would be like 2 seconds, and this is not acceptable, right? So we thought, okay, let's go ahead and add some simple indexes and see how it might improve the performance of fetching the events. So we thought the basic, like the simplest index would be like, since we want to fetch only those events that have not been delivered and had not been logged, had not been fetched by any other instance. So let's just create the single column indexes on log delivered and created that column. But this didn't help as much, as you can see that even the execution time still remains the same. So after a lot of research, we ended up with the actual final index as that you see on the screen. So the logic here was that like we first would like to use our static filter to filter out all those events which have not been delivered or have not errored or not have been archived. And once we get that, we want to sort them on the basis of those events which have not yet been delivered at all. That's why you see that log nulls first. Basically, that means events which have not been logged, and then the events which have not been set for a next retry, and so on and so forth. So the question comes, why did the last index didn't work? I mean, just because we add an index doesn't mean that it's going to guarantee faster execution times, right? So when we dug deeper, we just found out that for this previous index, what Postgres did was the Postgres query planner choose only the created at column as the index, and this ended up degrading the entire index search into basically a linear search. That means we kept on we kept on searching the entire row one by one and started filtering out events. That means this is bad because we are still going through all the processed events. That means we're double checking all the events in the table. So this did not work out. And secondly, why did this index work is because what we wanted was we wanted events that were not delivered, and that means the nulls value. When event is not delivered, the value of the delivered column is null. Okay, so when the value of the delivered column is null, by default in a normal Postgres index, all the null values are pushed to the bottom. That means you still have to go through all the processed event to reach to the events that have not been delivered. And this is not what we actually want. We want it to be the reverse. That is, all the log columns, all the events that have not been delivered to be at the top. So when you do this nulls first, the entire table gets sorted to the reverse. And that means you are not, this basically fastens up the entire process because you are first directly hitting the events which have not been delivered. So this was this was the reason that the change we made in the index works. The main point of this, okay, let's see the thing that happened. Like when we use this proper index for a row with some 20 million 20 million rows, we can see that the execution time was only 3 milliseconds. That's like a huge improvement from like 2000 milliseconds to 3 milliseconds. And again, the benefit of this was that even though the event log table grows, the execution style still the execution time still remains constant. That, as you can see here, like let's say we just take 10K rows, the execution time is still 3 milliseconds, and even let's take a 5 million rows, the execution time is still 3 seconds. And even though we reach some 20 million rows, the execution time is still 3.189 milliseconds. So this is how Hasura uses this complex indexes to actually fasten up the event delivery process. And yeah, that's it.
All right, thanks. And really appreciate the engineering team that are constantly optimizing how we query content or be able to surface those kind of functionalities so that we can pass on those performance wins to our users. So really appreciate the kind of work going behind that. So thank you. We have a really great demo up next, and it's on streaming subscriptions, which we've shown a number of times. And but this one is now actually a benchmark that we think is pretty impressive. So I'm not going to spoil it too much, but I'm going to go ahead and invite Karthik to come on and show us what we've got.
I'm Karthikeyan, and I work on the server side of Hasura, and I work a lot with the subscriptions and the eventing subsystem we have. Which I'll be today. I'll be talking about the streaming subscriptions feature. Not exactly the feature, but the benchmarks I did recently. So I'll like share what I found out and how the process was like. Okay, so we ran the benchmarks at different levels of concurrency, but it says 100,000 and 1 million streaming subscription, but that's not really true because I started from 1, then 100, then 1,000, like to check if the infra would hold up, and that was I mean, this sort of thing was a new thing for me, so I had to go like from one. So yeah, I did a lot of benchmarking at various levels of concurrency and found like really interesting things. Okay, so the tools and the infrastructure I use to run the benchmark. So at Hasura, we have this wonderful benchmarking tool, which can be used, which is the GraphQL. It is called the GraphQL bench, where you can give like any, you could give like any query or subscription, and it will like, you could specify the number of requests you want to make, the number at the frequency you specify. So it is like an amazing tool. Okay, and then we use AWS quite a lot. We use the AWS app runner to deploy the Hasura instances, the AWS Fargate, so that I don't have to manually like set up like hundreds of instances of Hasura, and like we had a giant AWS RDS Postgres instance for to hold up against the benchmark I was doing. Okay. So the benchmark I did was, so I had a messages table, and every second there were like 10K messages being written to the table. And then using the GraphQL bench, I started as a streaming subscription for a user, uh, with a random starting point. The streaming subscriptions was streaming on the ID value, and the tool has a feature where you could like randomly generate a ID, and the streaming subscription started from there. So this was how and this also had authorization. So it's not just that we took a very optimal query which we know would do well, good, but we took a query which had authorization, which looked like resemble real world use cases. Okay, so the 1 million, so actual instances. So the RDS, 16 CPUs and 32 GB RAM, and yeah. So while benchmarking, I ran up a pretty high bill on AWS, but lots to do. Okay, and then I had 100 in uh, um, 100 instances running in Fargate, and then 100 instances. I no, I actually the third point is wrong. I just had 10 instances of GraphQL bench, and they ran like 100K subscriptions. So this was the infra setup. Okay, so these are some graphs. I'm sorry, the graph don't look actually good, but it's that I took it at a um, wrong frequency. So the CPU, I'll show all these stats at the last in a table, so you just see that. So this is the DB CPU utilization. So you see that even though there's like 1 million subscriptions running, the DB CPU utilization is nothing crazy. Like it doesn't like even cross the 30%. And then yeah, the DB connection. So the DB connections, the max DB connections was set to 5,000, and we are like nowhere near it. Running 1 million benchmarks, 1 million subscriptions. So if you wanted to see the numbers, so these are the numbers. So we from the previous graph, you could see that we uh, there are about 2768 DB connections, which means that per DB connections there are like it handles to 361 subscribers. So it's like pretty cool. uh, I mean, this comes through, this happens due to the multiplexing magic that happens, uh, uh, which is done by Hasura. So but if you also see the other stats, it is it doesn't look anything crazy. Maybe the Hasura CPU a bit, but still, I mean, if you're considering the fact that it's 1 million, it is like okay, like it's nothing crazy. Okay, so that's all from my side. I'll be happy to answer any questions that you may have.
No, really a fantastic test, and it is something that we do have sort of a culture of trying to stress test it ourselves first, but before we hand it off to customers to be able to, and users to be able to kind of test it themselves. So we really appreciate that. Great talk. If you have any questions about that, definitely reach out here in chat, or even if you have any questions, GitHub issues or Discord, all great places to bring up further questions, because I'm sure there are going to be questions about that. So really great. Thanks again. And yeah, we love seeing that kind of science in the background. Up next, we're going to be having a look at the naming conventions and GraphQL customizations, which we saw metadata edition a few months ago, but now we actually get to see the UI side of it.
Amazing. So folks, today I'll be talking about GraphQL customizations for databases and naming conventions. Like Jesse mentioned, we had demoed the server and just the API side of it in the past community calls, but today we have added, recently we've added support for the console side of things. So I would just like to revisit the feature and take you over how it looks like, you interacting with the feature using the console. With that, I'm just going to dive into the demo. And right, so as we folks can see, I have a Hasura instance running here, and I have a database called PG1 connected with a simple author and article schema in it. So if we head over to the API tab, you can see that you have articles and authors as your fields that are being exposed. So what I'm going to do is try to connect a new database. What I'm doing actually is just connecting the same database, but again, the reasoning I'll probably explain in a second, but I'm going to call it PG2, and I'm going to go ahead and try to type it out without making typos. Right, that looks good. And connect. So as you see, I managed to connect my database PG2. And if I head over to the public schema, you can see that I have the article and other tables here again. So what I'm going to try to do is go and track this particular tables that we have in this data source. And as you would imagine, we see an error here. The reasoning for this error is pretty obvious. We already have author and article tables that have been created in the PG, that were part of the PG1 database, and they're already exposed over the GraphQL API. And us trying to track another table with author and article is going to lead to a conflict. So what we could do now instead is we have the ability to customize the GraphQL fields that are generated off a database. So if I head over to the edit section of the database, and we see the section where we can have GraphQL field level customizations. So I'm just going to go ahead and set a bunch of values here, and I'll explain what each of them does. So as you see here, we have the first section here is the naming conventions. By default, the Hasura default is what's being chosen, but for the purpose of the demo, I'm going to choose the GraphQL default, which changes the naming conventions from your snake case to a camel case style naming convention, which is useful in certain languages. What else I'm going to do is I'm going to add this data source I'm going to add a namespace for this particular for the database, and I'm going to call it NS. I'm going to add a prefix and suffix. So root pre, root suff, and just going to add a bunch of values here, and we will soon see what the impact of these values are. There we go. I'm just going to add these values, and I'm going to update the connection. So now if I head back to my public schema and I try to track all the tables, you see it kind of goes through and there are no more conflicts anymore. I'm going to go ahead and track all the relationships as well. So now if I head back to the API tab, what you can see is we have this new field got added to the top, which is called NS. So this is the namespace we just created. And you can see all the fields that were part of this database are now under this NS namespace. What we also see is this root pre and the root suffix that have been added to each field type that was generated. So as you would see here, the typical thing would have been called just article, but now we have root pre, article, and root suffix added to that just because I defined a prefix and suffix for the field types. Also, if I head a little deeper and if you would see the types of, if you see the types that are being created for this particular database, we would be able to see that all the types of this particular database have the type pre and the type suff kind of added to that. So we've been able to add a prefix and a suffix to the types and a prefix and a suffix to the field names as well. Also, what we noticed is because of the naming convention I said, you would notice that all the fields that have been created are in camel case as opposed to snake case, which is the default. Like you see here, we have article by PK, but when I use the GraphQL default naming convention, we end up with article by PK, but in camel case. So that's the feature in a sense. Basically, whenever you connect a database, you have more flexibility on what the actual GraphQL API that gets generated, and yeah, that has many use cases. That's basically what my demo was. We have very similar functionality for remote schemas as well, where a remote schema is an external GraphQL API that you connect to Hasura, and you can do pretty much very similar stuff with remote schemas as well. So yeah, so as we kind of saw, the Hasura kind of lets you to add GraphQL fields for a particular database under a particular namespace. It also lets you customize the auto-generated field and type names generated for your database objects. And the typical use cases that would help, this feature would help out is if you would have lots of databases that you're adding and connecting to Hasura, this could help you identify which fields and which types are coming from which particular database. It also helps you group all the fields and fields that have been generated by a particular database. Like for example, we added all the fields of PG2 under the NS namespace. And of course, we can always resolve conflicts with existing GraphQL objects. So it's situations where we have two data sources which have objects with the same name. This helps you, modify the types and the field names, so you can expose both of them. For the naming conventions as well, like I said, the most typical use case, it's mostly an aesthetic thing to have an API in a certain casing, and it's really useful for people who are consuming the API through languages like JavaScript, and JavaScript uses the camel casing as its default style. So all the types which get generated on the API calls that you make would also be in camel casing, which fits really well with the JavaScript ecosystem. So yeah, that was the feature, and thank you.
All right, thank you, Rick. And I can already, yeah, I can see there's a question already in chat, so I'll let you pick that up in chat as we get on to the next one here. But thanks again. That is a feature that does actually have a lot of very real world applications. So something that we're excited to be able to offer. And yeah, you would be surprised how many people just stick with the name user as like top level models in every single API they're shipping. It's like, yeah, but now we can handle it. So we really appreciate that. Thanks again, Rickon. Yeah, we have the next talk up is Parameterize Array Variables and Subscriptions, presented by Tom. Tom, are you ready?
I'm Tom. I'm on the native databases team with Abby. I'm quite new, so this is the first time I've demoed anything with this laptop, so apologies for that. To come back to the point earlier about subscriptions, the feature or the fix that I want to demo is kind of a little performance win, maybe to help some more benchmarking in the future. So with a query, generally, you write some GraphQL, we convert that to a query, we send it to the database, we get a result, and that's the end of it. When it comes to subscriptions, obviously what we want to do is poll that database. So we are going to send some information to the database over and over again to get responses back. And that can be quite inefficient if the query is quite large. So one of the things we tend to do is say we have this little one, to use everyone's favorite example of articles and authors. If we analyze it, we find that my variable, the author ID, is listed as synthetic, which is to say that we prepare the query and then we can just substitute in this variable. So what that means is when we poll the database over and over again, instead of sending an entire query, we just send that variable, and the traffic over the wire gets a lot less. So less load on the database, hopefully faster performance, everyone wins. Unfortunately, we did have a problem where if, say, you were sending an array, so an array of authors rather than a single one, at the time or in the current release, we couldn't prepare that argument. So if the analyzer loads, what we did was we just inlined that array. Now, what that means is if you want to send some more data over the wire, you have to send the entire query again. And if that array is very big or the query is very big, that creates a lot of overhead. So tempting fate yet again, if I take this and do some really quick live coding, and say I have, let's say, 2 authors like that. Everything's fine. And if we look now, what we see is that is now an integer array that we are preparing. So in terms of what you actually see, nothing has changed. But behind the scenes, the information we are sending over the wire has decreased. And hopefully you should see some performance wins, especially in the cases where you're batching a lot of subscriptions together and you're saying, you know, in this case, select any of these 200 authors. So yeah, hopefully a nice little performance win. And all nicely behind the scenes. Thanks very much.
Thank you, Tom. And while you may be new to Hasura, you are definitely not new to the type languages ecosystem. And these kind of performance wins are the things that we're super excited to have you here to be able to help us get shaped up. And yet again, another performance win for the community from some of our talks today. Really great to see. Do we dare tempt fate here and try to squeeze Brandon and Gavin in? Gavin and Brandon, how do you feel about it?
I don't know if 5 minutes is gonna be long enough, so it depends on how.
All right,
I think
then it's
maybe
a teaser for next week.
Okay, sounds good.
All right, I have to say I am super excited for that demonstration because I've heard about it. It sounds crazy nerdy. I mean, you don't expect anything less from those two. Yeah, so it's going to be a teaser. You're gonna have to come back next week to see what that's going to be about. We have a lot of really cool stuff to see. But thanks for being available to jump in there. I'm going to go on to the community demo. Enrique, are you ready to show us your Telegram bot?
Hello. I'm just gonna show you a little bit. It's a very simple example, but I think the main thing is the integration and the use case. What I think. Let me show. What we have done is to put the Hasura integration with with a Postgres database, and we made it very simple just by having a new bot from the bot father from Telegram. If I'm not sure if you're aware of how bots are created, but it's as easy as just ask the bot father to give you a number, and then that gives you a link. So with this bot father, we can send then connect to a Postgres database, and here I have one link that I so what we have done is to link by Hasura events and the database, so we can have the actions of our bots are defined in the tables. So we don't need to program the bots. Now we just need to make web links, webhooks, PDFs, or pictures to be able to relate to our bot. And that's really cool, because what we do is just define on the bot. For example, here we can send an email, or maybe execute a GraphQL, and we define that those this is the things we do, maybe a menu photograph, and then when we have Telegram, and we send a picture to our bot, then that picture can be used to can be sent directly to the database, and then the bot is gonna respond. This is the picture is received, and then we can see that picture in our S3 in the link. So what is cool about this integration, that just by using the database and the Hasura events, we can get the pictures, photos, and videos, documents, responses, inputs, and menus from the Telegram bot. So I think this is a very nice way to test the example. Here we have the picture. Here's what I sent. And then, so we can use this to integrate to have the Telegram API and use Hasura and OpenFast and Node.js and a Docker. So we build the bot. So with this, we can integrate very easily the bot with our applications. And the actions are very cool because we can send pictures and voice message and respond directly with Hasura. What I'm just in love how Hasura can integrate these executions from the database to the webhooks and integrate all them together. So I think if what I like about this is that this can be used in many situations. For example, we have done this to put together an ERP from our database using Hasura and then make the response to the bots, to the Telegram bots. So we have document, all this is integrated in the database. So what I'm really happy is that we can relate this this structure of Hasura events and subscription. So here we have all the actions we take, and the code is really interesting. We can send these intro actions from Hasura in and out. And the best thing is to use by using these events from Hasura, and I can send you some the code and an example later on if anyone is interested in this subject. Thank you. I just wanted to show how interesting this is for us and the applications we have done, because it saved us a lot of time just by using these connections with Hasura.
Yeah, thank you, Enrique. That was a really great demonstration. That's one of those examples where chat apps are actually a really driving functionality in a lot of the world, and it's a great built-in interface and a way to capture data. I love that you can actually go from that mobile to other applications, dashboard, ERP system. I think our community will love to actually see that code. So we'll reach out and actually try to set up maybe a technical blog or something together and be able to get a bit more of a write-up. We unfortunately had some internet difficulties from Milan today, but we really appreciate you joining us while you're out traveling. And this was really a great chat. I came across the Telegram bot father about a week prior when you reached out, and I was curious about it. And then somebody reached out and said they'd done it. And I was like, oh, fantastic. So we really appreciate you taking the time today. So thanks again. And we'll reach out to try and get something put together, because this, I think, really does need to be a piece of content that the community will really enjoy. With that being said, I'm going to go ahead and share my screen here. We have a couple of last-minute announcements to just run through. And what I want to just quickly say, so the community updates we have, the Data and API show, if you realize we were actually off for the last few weeks, taking a bit of a summer break, but we're coming back, and it is all about that database. So yeah, we're going to be doing a whole bunch of series, a whole bunch of shows all around databases, database performances, surfacing really cool tips and tricks, everything that you wanted to know about the deep internals of Postgres, everything we can get our hands on. So it's going to be a lot of fun as we really do a deep dive on that topic, because the Hasura story is a data story, and being able to use databases well will just only enhance your experience with Hasura. So we're super excited about that. If you've got a database story to tell, if you've got interesting things to show about databases, reach out to me on Discord, and I'm happy to have a chat and see if maybe there's something that even you could show to our community. That being said, our next community call is going to be in August, so I think I've hyped it enough already. We have a lot of really great stuff to show. We have also a fantastic new format we're going to test out, where it's going to be much more community involved. We're going to have a lot more Q&A, and we're going to be going through fewer topics, but actually tearing it apart as a community and actually discuss them, and maybe some RFC type of behavior. So we're super excited about that. We're wanting to really use this time as an opportunity to hear you and hear your feedback about features. So we're really excited about that. Stay tuned to your emails to kind of see which topics we'll be going into there. If you have any questions or you are wanting to reach out to, I'm guessing Enrique is probably reachable there as well, but Discord is where you can find everything about the Hasura community and where all of our users are. So we would love to actually have you come by and say hi. It's a great place to just talk with the community, show off what you've built, or even just get to know the team. So it's a fantastic place to meet all of us, and we'd love to see you over there. If you have any feedback about this show, how to make it better, or even if you'd like to contribute, you can reach out to us at /com10. This is a great opportunity for you to be able to reach out to us. Let us know what it is that you want to share. That being said, that wraps us just 2 minutes shy of the deadline for tonight's show. I want to say a big thanks to all of our speakers today, everybody who's been working really hard to make the Hasura product better, performance wins, benchmarking, stress testing, the Amazon budget, everything that's involved there. And a special thank you to our community contributor, Enrique, because that Telegram bot actually looks super sick. So I was really excited to see that. With that being said, we're going to go ahead and call that a day. We just were happy to have you all here today, and we will see you all next time at the next show. Have a good one, everybody.